At 10:49 on a Tuesday morning in late April, a webcam mounted on a broken section of boardwalk inside Yellowstone National Park recorded something that has happened thousands of times before. The camera did not react. It has no reaction to give. It simply captured light across 12 seconds and stored the frames. What those frames show is a pool of near-boiling water lifting upward. The surface rises across a width of roughly 2 meters. Then it ruptures. A column of brown and grey climbs approximately 15 meters above the basin floor. Rocks and mud and steam rise together. Then the column collapses. Within an hour, the pool looks to an untrained eye the same as it did at sunrise. The webcam continued recording. It has continued recording ever since, watching water that has been emerging from the same hole in the ground for longer than any human institution has existed to keep track. The pool is called Black Diamond Pool. It sits inside Biscuit Basin, on the western side of the Upper Geyser Basin complex, a few hundred meters from the most famous geothermal feature on Earth. The webcam that captured the April 28th event is part of a monitoring network that did not exist 3 years ago. The network was installed after a much larger explosion at the same pool, in the same spot, in July of 2024. That earlier event happened in front of approximately 200 tourists. Several of them were filming with their phones. Rocks landed on the boardwalk within meters of where people had been standing seconds before. No one was killed. No one was seriously injured. The absence of casualties was a function of pure geometry. The rocks went where they went. The people stood where they stood. The two paths did not intersect. The boardwalk that used to run past Black Diamond Pool was torn out after that event and rebuilt farther away. The basin has been closed to the public since. The only witness to the April 28th event, and to the 4 others that have occurred at the same pool in the first 5 months of 2026, is the sensor network. 5 events, 5 months, 1 pool. This is not a sign of an impending supereruption. It is not evidence that the magma chamber beneath Yellowstone is filling or destabilizing, or about to produce the kind of catastrophe that dominates public conversation about this place. What it is something else entirely. It is the system doing what the system does. It is the ordinary physics of hot water under pressure, finding the path of least resistance, releasing energy that has been stored in a sealed conduit, resetting itself, and then beginning the same cycle again. The dangerous thing about Yellowstone, on every timescale that matters to a human life, is not the supervolcano. That is the dramatic story. It is the one that has been told in documentaries, in news segments, in disaster fiction, in the background anxiety of anyone who has heard that the park sits atop a giant magma chamber capable of producing an eruption that would alter the climate of the northern hemisphere. That story is not false. The magma chamber exists. The caldera has produced 3 supereruptions in the past 2 million years. It will almost certainly produce another one at some point in the geological future. But the annual probability of that event is roughly 1 in 700,000. The recurrence interval is measured in hundreds of thousands of years. The last such eruption was approximately 630,000 years ago. We are within the typical range of intervals between events, which means nothing precise about when the next one will occur. The probability that it will happen within the lifetime of anyone reading this sentence is vanishingly small. It is not 0, but it is small enough that it does not belong at the top of any list of genuine concerns about visiting or living near Yellowstone. What does belong at the top of that list is the category of event that Black Diamond Pool has now demonstrated 5 times in 5 months. The category is hydrothermal explosion. It sits second on the United States Geological Survey's official hazard ranking for Yellowstone, after large earthquakes and before lava flows, before small magmatic eruptions, and far before caldera-forming supereruptions. The annual probability of a moderate hydrothermal explosion somewhere in the park is on the order of 1 in a few decades. The expected number of small hydrothermal explosions, events of the scale that Black Diamond Pool has been producing, is multiple per year across the park's thermal basins. The ratio of expected small hydrothermal explosions to expected caldera-forming eruptions per year is on the order of 10 million to 1. 10 million to 1. This is not a ratio that has been widely communicated. It is not the ratio that emerges from the popular media framing of Yellowstone. It is not the ratio that most visitors carry in their minds when they walk the boardwalks at Old Faithful or Norris or Mammoth. And the gap between the actual hazard distribution and the public's perception of that distribution is one of the more consequential failures of science communication in the modern history of American geological hazards. The April 28th webcam footage is not dramatic by the standards of viral video. The column rises, the rocks eject, the steam dissipates. There is no sound on the feed. There are no tourists running. There is no music swelling. There is only a small pool in a closed-off corner of the park, doing what it has been doing for millennia, now being watched in a way it never has been before. To understand what that footage actually shows, and why it matters, requires stepping back from the supervolcano framing entirely. It requires looking at the physics of hot water. It requires understanding what a hydrothermal system is, how it operates, and why the same mechanism that produced a 15-meter column on a Tuesday morning in April also produced a crater 2.5 kilometers across at the northern end of Yellowstone Lake approximately 13,000 years ago. The scale changes, the mechanism does not. The same physics that lifts rocks from a pool in Biscuit Basin, scaled up by volume and depth and pressure, reshapes the surface of the park. And because that physics operates continuously, somewhere in the system at all times, the question is never whether another hydrothermal explosion will occur. The question is where. The question is when. The question is whether tourists will be standing in front of it when it does. This is not a question about the end of the world. It is a question about the management of a known, measurable, well-characterized geological risk. It is a question about how we monitor, how we communicate, and how we decide what level of residual risk is acceptable for a national park that receives more than 4 million visitors a year. It is a question that the sensor network around Black Diamond Pool was built to help answer. The network includes a seismometer placed within meters of the pool, capable of detecting shallow seismic activity that the broader park network cannot resolve from kilometers away. It includes an infrasound microphone array that localizes the energy and directionality of any explosion. It includes a water level pressure transducer dropped directly into the pool, recording continuous fluctuations in depth. It includes a temperature thermistor and a dissolved gas sampling line that analyzes the water for chemical signatures linked to disturbance in shallow hydrothermal systems. And it includes the webcam, mounted on a remnant of the destroyed boardwalk, watching the water with the kind of patience only a machine can sustain. That webcam is one piece of a much larger effort to understand what actually happens inside the thousands of thermal features scattered across Yellowstone's 8,200 square kilometers. The effort is driven by a simple recognition. Hydrothermal explosions occur on no warning, with energy sufficient to kill at close range, in places where people are sometimes standing. The 2024 event at Black Diamond Pool did not kill anyone. The 1989 event at Pork Chop Geyser in Norris Basin did not kill anyone. The 1959 Hebgen Lake earthquake, which is a different category of hazard entirely, killed 28 people. But the fact that Nefnaut has no hydrothermal explosion in the modern history of the park is not evidence that no one will. It is evidence that the dice have rolled a certain way so far. The distribution of ejection patterns is not perfectly known. The boardwalks are not infinitely far from the features. The geometry that saved the tourists in 2024 could easily have been different by a few meters. The April 28th event was small. The column reached 15 meters. The largest ejected rocks were the size of gravel to small cobbles. None of them traveled far enough to reach the relocated boardwalk, which was the engineering goal of the post-2024 reconstruction. But the fact that it was small does not make it insignificant. It makes it typical. It makes it a sample from the distribution. It makes it exactly the kind of event that occurs multiple times a year, somewhere in the park. Usually at night, usually under cloud cover, usually at features without dense instrumentation, usually without anyone noticing. The difference in 2026 is that someone is noticing, the instruments are recording, the webcam is watching. And what the instruments are showing is that the system is not stable at Black Diamond Pool. It is not returning to the quiet state that preceded the 2024 event. It is producing events at a rate approximately 10 times higher than its historical baseline. 5 events in 5 months. More than twice the rate seen in 2025. A frequency that now ranks as the highest documented for any single named feature in the entire modern instrumented record of Yellowstone. That does not mean the pool is about to produce a larger event. The data does not support a simple precursor model in which small explosions reliably foreshadow larger ones. The 2024 event was not preceded by an obvious sequence of small precursors. The prehistoric Mary Bay event, the largest documented hydrothermal explosion in Yellowstone's geological record, left no precursor record because there was no instrumentation to record one. The published literature does not show a consistent pattern by which small events predict large ones. The relationship, if it exists, is not predictive enough to function as a warning system. What the elevated rate does indicate is that the system beneath Black Diamond Pool is out of equilibrium. The 2024 event physically modified the conduit. It widened the throat. It cleared accumulated mineral deposits. It exposed new surfaces to the hot, chemically saturated water. And those new surfaces, all else equal, drive faster mineral precipitation. Faster precipitation means faster resealing. A conduit that is out of equilibrium will evolve toward equilibrium over time. The rate of that evolution can be elevated for years or even decades after a major perturbation. The 2026 sequence is most likely the system finding its new equilibrium. It is local to Black Diamond Pool. It is mechanistically isolated from anything happening elsewhere in the park, and it should be expected to gradually decay over months to years as the conduit walls stabilize. That is the interpretation with the strongest empirical support. There are others. The Basin reorganization hypothesis holds that disturbance in one part of the shallow plumbing system can propagate to other features over time, and that Black Diamond Pool's elevated activity may be the most visible symptom of a broader reorganization beneath Biscuit Basin. As of May 2026, the sensor network has not detected obvious anomalies at other basin features, but the coverage is less dense and the analysis is ongoing. The detection improvement hypothesis holds that some fraction of the apparent rate increase is simply a function of better instrumentation. A small explosion that would have gone entirely undetected in 2023 is now clearly recorded. The stochastic variability hypothesis holds that some of the clustering may be random chance, a cluster of events around an unchanged mean rate. The honest answer is some weighted combination of all of these, with the conduit modification interpretation almost certainly the largest contributor. The trajectory implied by that combination is continued small events at Black Diamond Pool over the coming months to years, with gradual stabilization, no expected escalation to a larger event at this specific feature, and continued closure of Biscuit Basin to the public as a precaution against the small but non-zero residual risk that the interpretation is wrong. That is the assessment. It is grounded in the data. It is consistent with the published volcanology of hydrothermal systems. And it is importantly the assessment that the entire monitoring network was built to test. The point of the webcam, the seismometer, the infrasound array, the pressure transducer, the thermistor, and the gas sampler is not to confirm what researchers already think. The point is to detect a deviation from what they already think and to give enough warning that the consequences of being wrong can be mitigated. The 2026 sequence at Black Diamond Pool is not by itself a precursor to anything dramatic. It is instead the system showing us, in real time, the category event that the public mental model of Yellowstone has been ignoring for decades. The question is whether we are finally ready to see it. The July 23rd, 2024 hydrothermal explosion at Black Diamond Pool was not the largest event of its kind in Yellowstone's recorded history. It was not the most energetic. It did not produce the highest column or eject the largest rocks. What it did was happen at the right time of day, in the right weather conditions, in front of the right number of people with phones in their hands, to become the first hydrothermal explosion ever documented on viral video. By the time the rocks stopped landing on the boardwalk, more than a dozen tourists had their cameras pointed at the pool. By the time the dust settled, that number was closer to 50. By the time the videos had been uploaded, edited together, and pushed through the algorithmic engines of every major platform, the term hydrothermal explosion had crossed from a phrase confined to volcanology journals into a phrase that ordinary people typed into search bars at home, in cars, on the subway, in line at coffee shops. The event happened at 9:55 in the morning, Mountain Time. The day was clear and warm. Biscuit Basin had its usual morning crowd, a few hundred people scattered across the basin's two boardwalks, with most gathered near Sapphire Pool and Jewel Geyser at the basin's main feature complex. Black Diamond Pool sat a bit apart from those features, on a separate spur of boardwalk that looped around the western side of the basin. In 2024, it was not a feature that most visitors paid particular attention to. It was roughly circular, about 10 meters across, with deep blue-green water and a continuous low-volume gas emission that produced a slight surface ripple. It looked to a tourist who had walked past Sapphire Pool's spectacular blue water, like a smaller and less impressive version of the basin's named attractions. People generally walked past it on the morning of July 23rd. The people on the boardwalk near Black Diamond Pool were the people who had paused there for a moment longer than usual. Perhaps because they had been reading the interpretive sign, perhaps because someone in their group needed to rest, perhaps because the morning light was particularly good for photographs. The first sign that anything was wrong was a low rumble. It was not loud. People described it later as a hum, as a vibration in the boardwalk, as a sound they felt in their feet before they heard it in their ears. It lasted about 2 seconds, then the pool surface heaved upward. The heave was unmistakable. The water rose in an instant by perhaps 2 meters, lifting in a domed shape that was to the tourists watching it immediately, and obviously something they should not be standing close to. People started running. Some dropped their phones. Some kept filming as they ran. The rise of the dome, the moment it ruptured into a column of brown and grey, the moment rocks began to fall on the boardwalk and onto the sinter apron, all of it is preserved in dozens of overlapping clips taken from dozens of angles by people running in different directions while their cameras kept recording. The column reached an estimated height of 30 to 40 meters above the pool's surface at its peak. The total event lasted about 30 seconds from first surface disturbance to final collapse. During those 30 seconds, the pool ejected an estimated 300 to 500 cubic meters of material, superheated water, mud, clay, and rock. The largest rocks ejected were on the order of 20 to 30 centimeters across. Several landed on the boardwalk. One broke a boardwalk plank. 2 landed within 5 meters of where tourists had been standing seconds earlier. No one was directly struck. No one was killed. No one was even seriously injured in the immediate event, though several people had minor injuries from the running and falling that followed. By any reasonable standard, the National Park Service and the Yellowstone Volcano Observatory researchers who later assessed the event agreed that the absence of fatalities was a function of pure geometry. The rocks went where they went. The people stood where they stood. The two paths did not intersect. What the rocks did do was damage the boardwalk. The section closest to Black Diamond Pool was destroyed in several places. The interpretive signage was thrown clear. The walking surface was no longer safe to use. By the end of the day, the Park Service had closed Biscuit Basin to the public. By the end of the week, the basin was announced to remain closed until further notice. The boardwalk infrastructure would be reviewed and likely relocated. The USGS would work with the Park Service to install additional monitoring at the pool itself. What unfolded over the next 21 months was the construction of a sensor network whose data is now the most detailed continuous record of hydrothermal explosion activity at any single feature in Yellowstone's history. The webcam mounted on a remnant of the destroyed boardwalk, the seismometer placed within meters of the pool, the infrasound microphone array, the water level pressure transducer, the temperature thermistor, the dissolved gas sampling line. A level of monitoring that exceeds what most other features in the park have ever received. The relocated boardwalk sits about 30 meters farther from the pool than the original. The viewing angle is different. The pool is still visible from the new boardwalk's perimeter, but the relocation creates a safety buffer that, in the assessment of the engineering review, would protect tourists from the kind of debris ejection pattern observed on July 23rd. The boardwalk has been closed to public access since the event, pending the Yellowstone Volcano Observatory's assessment that the pool has stabilized. As of May 2026, that assessment has not been made. The pool has not stabilized. The 5 events of 2026 are the evidence of that. The published analysis of the July 23rd event, which appeared in a peer-reviewed paper in early 2025 and in several USGS bulletin updates in the month between, settled on a mechanism that is now the standard interpretation for hydrothermal explosions at Yellowstone. The trigger was not a deep magmatic event. The trigger was not an earthquake elsewhere in the park. The trigger was a self-sealing, self-pressurizing cycle local to the conduit beneath the pool. Over a period of months to years before the event, mineral precipitation along the conduit walls had been progressively narrowing the throat of the system through which hot water rose to the surface. As the throat narrowed, the pressure of the water and steam mixture in the deeper conduit increased. The water beneath the seal was at a temperature high enough that it would have flashed to steam at lower pressure, but the pressure was holding it as liquid. When the seal failed, when the pressure inside the conduit finally exceeded the strength of the mineral deposit and the weight of the overlying water, the trapped water flashed instantly to steam. The volumetric expansion of that flash, at the temperatures and pressures involved, was on the order of a factor of 1600. That expansion is what drove the ejection. It is what lifted the dome of water. It is what threw the rocks. It is what produced the column of vapor and debris that reached 30 to 40 meters into the air above the basin floor. Everything that has happened at Black Diamond Pool since follows from that mechanism. The 2026 events are the same mechanism operating on a smaller scale. The April 28th event was the same physics: a sealed conduit, a pressure buildup, a failure, a flash to steam, an ejection, a collapse. The difference was the volume of water involved, the depth of the seal, the amount of energy stored. The same continuum that connects the April 28th event to the July 23rd event connects the July 23rd event to the 1989 Pork Chop Geyser event, and the Pork Chop event to the Mary Bay event 13,000 years ago. The scale changes. The mechanism does not. This is the baseline state of Yellowstone. The park contains more than 10,000 thermal features. Each of them sits atop a conduit or a network of conduits through which hot water rises from depth. Each of those conduits is lined with mineral deposits that precipitate out of the cooling, depressurizing water. Each of those mineral deposits narrows the conduit over time. Each narrowed conduit increases the pressure in the system below the constriction, and each increased pressure profile, if it crosses the threshold where the strength of the seal is exceeded, produces an explosion. Some of these explosions are too small to detect without instruments. Some throw rocks onto boardwalks, some reshape the surface of the park. Some create craters 2.5 kilometers across. The system is not special because it produces explosions. It is special because it produces them in a place where millions of people walk every year, on boardwalks that are sometimes tens of meters from active features, at times that cannot be predicted, on no warning that current science can provide. The escalation from the 2024 event to the 2026 sequence is not an escalation in magnitude. It is an escalation in frequency. 5 events in 5 months is not, by itself, geologically remarkable. What makes it remarkable is that it is happening at a single feature that researchers are watching more closely than any other feature in the park. And what that frequency tells us is that the system beneath Black Diamond Pool has not returned to equilibrium. It is still adjusting. It is still finding its new geometry. It is still producing events at a rate that, if it were happening at a feature with an open boardwalk, would have closed that boardwalk months ago. The question that the 2026 sequence forces is not about Black Diamond Pool. The question is about the rest of the park. If a feature that produced a moderate explosion in 2024 is now producing small events at an elevated rate, how many other features in the park are producing similar sequences without being watched closely enough to know? How many small explosions occur every year at features without webcams, without pressure transducers, without infrasound arrays, without anyone noticing? And what is the probability that one of those unobserved sequences is happening right now beneath a boardwalk that remains open to the public? The answers to those questions are not known. They cannot be known without a level of instrumentation that does not currently exist across most of Yellowstone's thermal basins. The sensor network at Black Diamond Pool is an exception. It is the exception that proves the rule, and the rule is that we are, for most of the park, flying blind. We know that hydrothermal explosions occur. We know their frequency-magnitude distribution. We know that small events are common and large events are rare. But we do not know, for any given feature on any given day, whether the conduit beneath it is sealed, how much pressure has accumulated, or when the seal might fail. The escalation at Black Diamond Pool is not a warning about that specific pool. It is a demonstration. It is a real-time example of what the system does when it is out of equilibrium. And it is an opportunity to ask whether the level of monitoring that exists at Black Diamond Pool should exist at more features across the park. Not because the park is about to experience a catastrophic hydrothermal event, but because the annual probability of a moderate event somewhere in the park is high enough that the residual risk to visitors is real. And because that risk can be reduced with better monitoring, better communication, and better boardwalk placement, the 2024 event did not kill anyone. The 2026 events have not killed anyone. But the distribution of ejection patterns is random. The geometry that saved the tourists in 2024 could easily have been different, and the next moderate hydrothermal explosion at Yellowstone will occur. The question is not whether. The question is where and when, and whether anyone will be standing in front of it. The study of hydrothermal explosions at Yellowstone sits at an uncomfortable intersection between two scientific cultures. The first is the culture of long-term geological process, which operates on timescales of thousands to hundreds of thousands of years, and is comfortable with uncertainty, with low probabilities, with recurrence intervals that exceed human memory. The second is the culture of hazard monitoring, which operates on timescales of days to decades and is expected to produce actionable information for public safety decisions. The tension between these two cultures is not a failure of science. It is an inherent feature of the problem. Hydrothermal explosions are geologically frequent but human rare. They occur somewhere in the park multiple times per year, but are rarely large enough to threaten human life. The base rate is high. The consequence distribution is heavy-tailed. The warning time is zero. And the public, which has been trained by decades of popular media to think about Yellowstone almost exclusively in terms of its supervolcano potential, has no intuitive framework for understanding a hazard that is more likely than the supervolcano by a factor of 10 million, but less dramatic by every measure of cinematic scale. The scientific tension manifests in several specific disagreements within the research community. These disagreements are not about whether hydrothermal explosions occur. They are about what the observed activity at features like Black Diamond Pool tells us about the state of the system as a whole, and about what level of public communication is appropriate given the uncertainties. The first disagreement concerns the relationship between small hydrothermal explosions and larger ones. One school of thought holds that small explosions are essentially independent events, each localized to its own conduit, each driven by local sealing and pressurization cycles that are not connected to broader system behavior. Under this view, the elevated frequency at Black Diamond Pool tells us nothing about the probability of a larger event at Black Diamond Pool or anywhere else in the park. It is simply that feature adjusting to the perturbation of the 2024 event. The rate will decay. Nothing more will come of it. The other school of thought holds that hydrothermal systems are interconnected at depth in ways that are not fully captured by surface observations. Disturbance in one part of the shallow plumbing can propagate through permeable fault zones and fracture networks to other features over timescales of months to years. Under this view, the elevated frequency at Black Diamond Pool could be the leading indicator of a broader reorganization beneath Biscuit Basin. That reorganization might express itself as changes at other features, or it might dissipate without further consequence, or it might in some low probability scenario accumulate toward a larger event. The evidence for interconnection is real. The 1959 Hebgen Lake earthquake triggered changes at thermal features across the park, including the dramatic transition of Sapphire Pool from a quiet hot spring to an active geyser. If an earthquake can trigger changes across tens of kilometers, then a hydrothermal explosion at one feature could plausibly trigger changes at nearby features through the same fault and fracture networks. The question is not whether interconnection exists. The question is how strongly the features of Biscuit Basin are coupled, and whether the coupling is strong enough that the Black Diamond Pool sequence should be interpreted as a basin-wide signal rather than a local anomaly. The available data does not resolve this question. The sensor network at other Biscuit Basin features is less dense than the network at Black Diamond Pool. Small changes that would be easily detected at Black Diamond Pool could be occurring at Sapphire Pool or Jewel Geyser or Black Pearl Geyser without being noticed. The absence of detected anomalies is not the same as the absence of anomalies. It is a statement about the limits of the monitoring. The second disagreement concerns the interpretation of the dissolved gas data. The sampling line installed at Black Diamond Pool in mid-2025 continuously analyzes the water for gases that the volcanology literature has linked to disturbance of shallow hydrothermal systems. These include carbon dioxide, hydrogen sulfide, methane, and helium isotopes. The ratios of these gases and their concentrations relative to each other can indicate whether changes in the system are driven by shallow processes like mineral precipitation, or by deeper processes like magmatic degassing. The preliminary data from Black Diamond Pool shows some variation in gas chemistry across the 2026 sequence. The variation is small. It is not clearly trending in any direction, but it exists, and different research groups interpret it differently. One interpretation holds that the gas variations are consistent with the conduit modification hypothesis. The explosion exposed new mineral surfaces, changed the flow path, and altered the residence time of water in the shallow system. The gas chemistry is adjusting to the new plumbing geometry. No deep signal is present. The other interpretation holds that some of the gas variations, particularly the helium isotope ratios, are more consistent with a deeper source. Helium-3 is a tracer of magmatic input. It is released from the mantle and from the magma chamber itself. Elevated helium-3 relative to helium-4 can indicate that fresh magma or magmatic volatiles are entering the shallow system. The data from Black Diamond Pool shows a small but measurable shift in helium isotope ratios in the months leading up to the 2026 sequence. The shift is within the range of natural variability observed at other Yellowstone features over the past several decades, but it is present, and it is not obviously explained by shallow conduit modification alone. The disagreement here is not about the data. The data is clear. The disagreement is about whether the observed shift is meaningful, whether it exceeds the background variability of the system, and whether it should be interpreted as a signal of deeper unrest. The honest answer is that no one knows yet. The data record is short. The 2025 installation of the gas sampling line means that the pre-2026 baseline is limited, and the natural variability of helium isotope ratios at Yellowstone features is not perfectly characterized because continuous gas sampling at this density has not been done before. The Black Diamond Pool gas data is new. It is being analyzed in real time, and the scientific community is, in a healthy way, disagreeing about what it means. The third disagreement concerns the appropriate level of public communication about the 2026 sequence. This is not a purely scientific question. It involves risk communication, public perception, and the psychology of low-probability, high-consequence events. The USGS has taken the position that the 2026 sequence does not warrant an elevated public alert level. The pool is in a closed basin. The relocated boardwalk is not accessible to the public. The monitoring network is functioning. The probability of a larger event is low. The appropriate communication is routine updates on the Yellowstone Volcano Observatory's public dashboard and occasional social media posts. Some researchers outside the USGS have argued that the public communication should be more emphatic. Not because the risk is high, but because the public's mental model of Yellowstone hazards is so misaligned with the actual hazard ranking that any event that demonstrates the real hazard should be used as a communication opportunity. The 2024 event reached tens of millions of people through viral video. The 2026 sequence, if framed correctly, could reach a similar audience. The argument is that the USGS has a responsibility not just to report data, but to actively correct public misperception, and that the Black Diamond Pool sequence is the best data the agency has had in decades for doing so. The counter-argument is that emphatic communication about a low-probability event risks being interpreted as alarmism, and that alarmism about a hazard that is genuinely less likely than driving to the park would undermine public trust in the agency's communication about higher probability hazards. The USGS has been accused of both under-communicating and over-communicating about Yellowstone at different times. The record suggests that the agency's default mode is caution. It communicates what it knows. It acknowledges uncertainty. It does not speculate about worst-case scenarios unless the data supports them. This approach has strengths and weaknesses. The strength is that it preserves credibility. The weakness is that it allows the public's misperception to persist. The fourth disagreement concerns the budget for hydrothermal monitoring. The USGS has, in its budget request to Congress, consistently asked for additional funding to expand the monitoring network at Yellowstone. The requests have been partially funded. The Black Diamond Pool network was funded in part by emergency supplemental allocations after the 2024 event. The rest of the park's thermal basins have monitoring that ranges from moderate to sparse. The disagreement is not about whether more monitoring is needed. There is broad consensus that it is. The disagreement is about how much additional monitoring would be cost-effective given the low probability of a large hydrothermal explosion, and the even lower probability of one occurring at a specific feature with tourists present. One view holds that the monitoring should be expanded to all major thermal basins, with instrumentation comparable to the Black Diamond Pool network at each basin. The cost would be substantial, but the annual visitation to Yellowstone is over 4 million people, and the park is a national asset. The other view holds that the Black Diamond Pool network is appropriate for a feature that has demonstrated elevated activity, but that expanding the same level of monitoring to all features would be prohibitively expensive and would not meaningfully reduce the residual risk because the probability of a harmful event at any specific feature in any given year is extremely low. The monitoring should be targeted. The features with the highest historical activity, the highest visitation, and the most concerning geological contexts should receive the most attention. Everything else can be monitored at a lower density. This disagreement is fundamentally a resource allocation question. It is not resolvable by science alone. It involves value judgments about how much risk is acceptable, how much money should be spent to reduce that risk, and how to prioritize Yellowstone relative to other geological hazards in other parts of the country. The scientific tension at the heart of all of this is that hydrothermal explosions are both well understood and poorly predicted. The mechanism is clear. The frequency magnitude distribution is reasonably well characterized. The physics of flash boiling and volumetric expansion is not in dispute, but the ability to say, for any given feature, on any given day, whether it will explode in the next hour, does not exist. It may never exist. The timescales of the sealing process are years to decades. The failure of the seal is sudden and unpredictable. The precursor signals that do exist, such as changes in water level, temperature, gas chemistry, and seismicity, are subtle and often ambiguous. They can indicate that a system is approaching failure. They can also indicate that a system is simply fluctuating within its normal's range. Disentangling the two requires long records, dense instrumentation, and a willingness to live with uncertainty. The 2026 sequence at Black Diamond Pool is, in this sense, a gift to the scientific community. It is producing data at a rate that no previous sequence has produced. The seismometer is recording the shallow seismic activity associated with each event. The infrasound array is localizing the energy and directionality. The pressure transducer is capturing the sudden drop in water level and the refill rate. The thermistor is recording the temperature shifts. The gas sampler is measuring the chemical changes. And the webcam is providing visual confirmation that ties all of the sensor data to an observable physical process. The sequence is a natural experiment. It is testing the interpretations. It is generating the kind of high-resolution data that can resolve disagreements. But the sequence is also, unavoidably, happening in real time. The data is coming in as the system evolves. The interpretations are being updated continuously, and the public, to the extent that it is paying attention, is watching science happen in a way that is usually confined to journals and conferences. This is uncomfortable for scientists who are used to working at a slower pace. It is also, potentially, valuable. The public has a chance to see how science actually works. The disagreements, the uncertainties, the gradual accumulation of evidence, the honest admission that some questions cannot yet be answered. That is not a failure of science. It is the process. The tension between the need for clear communication and the reality of scientific uncertainty is not going to be resolved. It is going to be managed. The USGS will continue to issue updates. The researchers will continue to publish papers. The webcam will continue to record. And the pool will continue to do what it has been doing for thousands of years. The only question is whether the public, over time, will develop a more accurate mental model of what that actually means. The boardwalks at Yellowstone are engineered structures. They are designed to keep visitors at a safe distance from thermal features. The distances are determined by a combination of historical experience, hazard assessment, and engineering judgment. The assessment that went into the original boardwalk at Black Diamond Pool, the one that was torn out after the 2024 event, concluded that a distance of roughly 15 meters from the pool margin was sufficient. That assessment was wrong. The 2024 event ejected rocks that landed on the boardwalk. The rocks did not hit anyone, but they landed where the assessment said they would not land. The boardwalk was rebuilt at a distance of approximately 30 meters from the pool. The new distance reflects the lesson of the 2024 event. It incorporates a larger safety buffer. It assumes that the debris ejection pattern observed in 2024 is the relevant envelope for future events. That assumption is reasonable, but it is an assumption. The largest hydrothermal explosions at Yellowstone, the Mary Bay class, eject blocks that travel kilometers. The probability of a Mary Bay scale event at Black Diamond Pool is extremely low, but it is not zero, and the boardwalk distance of 30 meters would provide no protection against such an event. The boardwalk is designed for the moderate event, not the extreme event. That is a conscious trade-off. Engineering for the extreme event would require keeping the basin closed permanently. Engineering for the moderate event allows the basin to reopen if the pool stabilizes. The trade-off is reasonable. It is also a statement about the level of risk that the National Park Service is willing to accept on behalf of visitors. The human consequences of hydrothermal explosions fall into three categories. The first is direct physical harm, being struck by ejected rocks, being burned by boiling water or steam, being knocked down by the blast wave. The second is indirect physical harm, injuries sustained while running, falling off boardwalks, or otherwise evacuating in panic. The third is psychological harm, the experience of being near an explosion, witnessing the event, fearing for one's life, and carrying that memory. The 2024 event produced injuries in the second category. Several people were treated for minor injuries from running and falling. No one was treated for injuries from the explosion itself. That outcome is better than it could have been. It is also worse than it should have been. The fact that no one was killed does not mean the event was harmless. It means the harm was contained. The 1989 pork chop event in Norris Basin produced a similar pattern. Rocks landed within a few meters of tourists. No one was struck. No one was killed. The geometry of the ejection pattern saved the people who happened to be standing where they were standing. The 1989 event is often cited as evidence that hydrothermal explosions at Yellowstone are not particularly dangerous. That interpretation is incorrect. The correct interpretation is that the sample size is small and the dice have rolled a certain way. The probability of a fatal hydrothermal explosion at Yellowstone in any given year is not zero. It is not high, but it is not zero. And over a long enough time horizon, it becomes a near certainty. The human consequences are not just about fatalities, they are about the management of risk. The National Park Service has a legal and ethical responsibility to keep visitors safe. That responsibility is balanced against the mission of the park, which is to provide access to the geological wonders of Yellowstone. The balance is difficult. Closing a basin indefinitely has economic consequences for the surrounding communities. It limits the experience of visitors. It requires the Park Service to make judgments about acceptable risk that are inherently value-laden. The closure of Biscuit Basin after the 2024 event was an easy decision. The boardwalk was destroyed. The basin was unsafe. The closure was necessary. The continued closure of Biscuit Basin in 2026 is a harder decision. The boardwalk is rebuilt. The pool is active, but the distance is greater. The probability of a harmful event on any given day is low, but the probability is higher than it was before the 2024 event. The pool has not stabilized. The frequency of small events is elevated, and the Park Service has, so far, decided that the residual risk is too high to reopen. That decision is defensible. It is also conservative. It reflects a judgment that the uncertainty about what will happen next at Black Diamond Pool is large enough that the prudent course is to wait. The human consequences extend beyond the park boundaries. The communities that surround Yellowstone, West Yellowstone, Gardner, Cook City, Jackson depend on park visitation for their economic survival. A prolonged closure of a major thermal basin affects those communities. The closure of Biscuit Basin is not economically significant on its own. Biscuit Basin is a secondary attraction. Most visitors to the Upper Geyser Basin go to Old Faithful. They might not even notice that Biscuit Basin is closed. But if the logic of the Black Diamond Pool monitoring were applied to other basins, and if other basins were closed as a precautionary measure, the economic consequences would accumulate. Norris Basin, Mammoth Hot Springs, the Grand Prismatic Spring, all of these areas have thermal features that could, in principle, produce hydrothermal explosions. The probability of an explosion at any specific feature on any given day is low. The probability of an explosion somewhere in the park in any given decade is high. The Park Service cannot close every basin. It cannot eliminate the risk. It can only manage it. The human consequences also include the psychological burden on the researchers and park rangers who are responsible for making these decisions. The 2024 event was a near miss. The people who were close to it remember it. The people who are monitoring Black Diamond Pool today watch the webcam feed. They see the small events. They know that the system is not stable. They know that a larger event could occur, even if the probability is low. They carry that knowledge. They make decisions based on that knowledge. And they do so under the scrutiny of the public, the media, and their own scientific peers. There is a deeper human consequence that is harder to measure. It is the consequence of being wrong. If the Park Service reopens Biscuit Basin and a larger event occurs that harms visitors, the consequences will be severe. There will be investigations, lawsuits, changes in policy. The careers of the people who made the decision will be affected. The trust that the public places in the Park Service and the USGS will be damaged. If the Park Service keeps the basin closed for years and the pool eventually stabilizes without producing any larger events, the consequences will be different but also real. Visitors will have been denied access to a thermal basin for no observable reason. The surrounding communities will have lost economic activity. The Park Service will be accused of overcaution, of wasting resources, of keeping the public away from something that was never dangerous. There is no perfect decision. There is only the decision that seems best given the available information. The human consequences of hydrothermal explosions at Yellowstone are not, in the grand scheme of geological hazards, large. The number of people who have been killed by hydrothermal explosions in the United States in the past century is zero. The number of people who have been killed by volcanic eruptions in the United States in the past century is small. The risks are real, but they are not, in aggregate, large. The reason they matter is not the absolute number of expected fatalities. It is the mismatch between the public's perception of the risk and the actual distribution of the risk. The public worries about the supervolcano. The public does not worry about hydrothermal explosions. The data says the opposite order of concern is appropriate. The human consequence of that mismatch is misallocated attention. It is money spent on disaster preparedness for the wrong disaster. It is fear directed at the wrong thing. It is a failure of science communication that has persisted for decades. The 2024 event was an opportunity to correct the mismatch. The viral videos reached millions of people. The term hydrothermal explosion entered the popular vocabulary. The opportunity was real, it was also fleeting. The public's attention moved on. The supervolcano framing reasserted itself. The mismatch persisted. The 2026 sequence is a second opportunity. 5 events in 5 months. A webcam recording in clear light. A sensor network producing data that was unimaginable a decade ago. The opportunity is here. Whether it will be used is a question about media, about education, about the public's appetite for understanding the actual hazard rather than the imagined one. It is also a question about the willingness of the scientific community and the Park Service to communicate the hazard in a way that lands. The data is clear. The hazard ranking is unambiguous. The threat is not the supervolcano. The threat is the boardwalk you are standing on, the pool you are looking at, the conduit beneath your feet that has been sealing and pressurizing and failing for thousands of years. The human consequence of the current communication failure is that visitors to Yellowstone do not know what they should be paying attention to. They do not know that hydrothermal explosions are more likely than the supervolcano by a factor of 10 million. They do not know that the boardwalk distances are engineering judgments, not guarantees. They do not know that the 2024 event was a near miss. They walk the boardwalks, they take the pictures, they go home. And the system continues to do what it has always done. The goal is not to scare people away from Yellowstone. The goal is to provide an accurate mental model of the hazards that actually exist. The goal is to enable informed consent. Visitors should know that the risk is real, that it is small, that it is managed, and that they are accepting it by choosing to walk the boardwalks. That is not alarmism, that is honesty. And honesty is the foundation of trust. The 2026 sequence at Black Diamond Pool is giving the Park Service and the USGS an opportunity to be honest. The pool is exploding. The webcam is watching. The data is public. The only question is whether the public will be told, clearly and repeatedly, what that actually means. A hydrothermal explosion does not occur in isolation. It is an event in a system. The system includes the conduit beneath the pool, the shallow plumbing network that connects features within a basin, the deeper hydrothermal reservoir that supplies water and heat, and the fault and fracture networks that control fluid flow. An explosion that modifies one part of the system has the potential to propagate effects through other parts. The magnitude of those effects depends on the scale of the explosion, the connectivity of the system, and the pre-existing state of stress and fluid pressure. The cascading effects of the 2024 Black Diamond Pool explosion are still being understood. The immediate effects were local. The pool's vent was widened. The conduit was partially cleared. The sinter apron was disturbed. The boardwalk was destroyed. The basin was closed. The longer-term effects are what the 2026 sequence is revealing. The elevated frequency of small events is a cascade. It is the system adjusting to a perturbation. The adjustment is not happening in a straight line. The 2024 event was followed by a period of elevated activity in the second half of 2024, then a quieter period in 2025, then another period of elevated activity in early 2026. The pattern is not simple. It does not follow a clear decay curve. It suggests that the system's response to the 2024 event is ongoing, and that the time to stabilization may be measured in years, not months. The cascading effects could, in principle, extend beyond Black Diamond Pool. The shallow plumbing of Biscuit Basin is interconnected. The features share fluid pathways at depth. A perturbation at one feature can change the pressure distribution in the shared reservoir, which can alter the behavior of other features. The 1959 Hebgen Lake earthquake demonstrated this principle at the scale of the entire Upper Geyser Basin. The earthquake produced a pressure pulse that propagated through the shallow hydrothermal system, triggering changes at features across the basin. The transition of Sapphire Pool from a quiet hot spring to an active geyser was the most dramatic example. That transition was permanent. Sapphire Pool has never returned to its pre-1959 state. The question raised by the 2024 explosion is whether a similar, though smaller, pressure pulse was transmitted through the Biscuit Basin plumbing. The explosion ejected material. It created a void in the shallow conduit. The refilling of that void drew water from the surrounding reservoir. The sudden movement of water could have propagated pressure changes to nearby features. The sensor network at those features is not dense enough to say definitively whether such pressure changes occurred. The absence of observed changes at Sapphire Pool, Jewel Geyser, and Black Pearl Geyser is not proof that no changes occurred. It is proof that no changes large enough to be detected by the existing instrumentation occurred. The existing instrumentation at those features is less sensitive than the instrumentation at Black Diamond Pool. Small changes that would be easily detected at Black Diamond Pool could be occurring at other features without being recorded. The cascading effects of a larger hydrothermal explosion of the scale of Mary Bay or even Pork Chop would be more dramatic. The Mary Bay explosion created a crater 2.5 kilometers across. It ejected material across the surrounding landscape. It would have, if there had been a modern hydrothermal system in place, disrupted the shallow plumbing across a wide area. The crater itself is evidence of the scale of the disruption. The fact that the system continued to operate after Mary Bay, that hydrothermal features exist in the area today, is evidence of the system's resilience. The cascading effects were temporary. The system recovered. But the recovery took time. The geological record shows that the area around Mary Bay was hydrothermally active after the explosion, but the activity was different. The distribution of features changed. The system found a new equilibrium. The cascading effects of a hydrothermal explosion on the park's infrastructure would be significant. The road network in Yellowstone is vulnerable to thermal activity. Roads have been damaged by thermal features before. The Firehole Lake Drive, a scenic road near the Upper Geyser Basin, has been repeatedly damaged by thermal expansion and subsidence. A hydrothermal explosion that occurred beneath or near a road could destroy the road surface, cut off access to parts of the park, and require months or years of repair. The same is true for the park's trails, boardwalks, and buildings. The Old Faithful Inn, the historic lodge that sits within a few hundred meters of the Upper Geyser Basin's active features, is not at high risk from a hydrothermal explosion at any specific feature. But a moderate explosion at a feature near the lodge could produce debris that reaches the building. The probability is low. It is not zero. The cascading effects on the park's geothermal features themselves are the most scientifically interesting. A hydrothermal explosion that modifies a feature can change its behavior for years or decades. The Pork Chop Geyser did not return to its pre-1989 state. It is no longer a geyser. It is a small crater. The Sapphire Pool did not return to its pre-1959 state. It is a more active feature than it was before the earthquake. The Black Diamond Pool has not returned to its pre-2024 state. It is producing events at a higher frequency. The new equilibrium, when it is reached, will be different from the old equilibrium. The pool will not be the same as it was. The cascading effects of the 2024 explosion are still unfolding. The pool is still changing. The sensors are still recording. The broader cascading effect that matters most for public safety is the effect on the Park Service's risk management framework. The 2024 event demonstrated that the existing boardwalk distances were insufficient at Black Diamond Pool. The distances were based on an assessment that did not anticipate the ejection pattern observed in 2024. The question that follows is whether the boardwalk distances at other features are also insufficient. The answer is that no one knows. The ejection pattern of a hydrothermal explosion is not perfectly predictable. It depends on the geometry of the conduit, the volume of water involved, the depth of the seal, and the direction of the failure. The same feature could produce different ejection patterns in different events. The 2024 pattern was one realization. Another event at the same pool could produce a different pattern. The distances that are safe for one pattern may not be safe for another. This uncertainty is not a failure of engineering. It is a feature of the system. The Park Service and the USGS do the best they can with the available information. They update the distances when new information becomes available. The distances at Black Diamond Pool were updated after the 2024 event. The distances at other features have not been updated because no comparable event has occurred at those features. The absence of an event is not proof that the distances are sufficient. It is proof that the dice have not rolled in a certain way. The probability that a harmful ejection pattern occurs at a given feature in a given year is low. The probability that it occurs somewhere in the park in a given decade is not low. The Park Service cannot eliminate the risk. It can only respond to events as they happen. The cascading effects of the 2024 event on the scientific understanding of hydrothermal explosions are substantial. The data from the Black Diamond Pool monitoring network is the highest resolution record ever collected of a hydrothermal explosion sequence. The seismometer, the infrasound array, the pressure transducer, the thermistor, the gas sampler, and the webcam are producing a dataset that will be analysed for years. The dataset will improve the understanding of what happens in the minutes, hours, and days before a small explosion. It may reveal precursor signals that were previously unknown. It may show that certain patterns of water level fluctuation, temperature change, or gas chemistry are reliably associated with imminent failure. It may not. The dataset is what it is. The analysis will take time. The scientific cascading effects extend beyond Yellowstone. Hydrothermal systems exist all over the world. The lessons learned at Black Diamond Pool will apply to systems in Iceland, New Zealand, Italy, Japan, and elsewhere. The instrumentation that was installed at Black Diamond Pool can be installed elsewhere. The analytical methods developed to interpret the data can be applied to other datasets. The understanding of hydrothermal explosion mechanisms will improve. The ability to monitor and, perhaps one day, to provide warning will improve. That is the long-term cascade. It is the cascade that matters most. The 2024 event was a local event with global scientific consequences. The 2026 sequence is adding to those consequences. Every event adds data. Every data point improves the understanding. The understanding will never be perfect. The warning time may always be measured in seconds. But better understanding means better risk assessment. Better risk assessment means better decisions about boardwalk placement, basin closures, and public communication. The cascading effects of the 2024 event and the 2026 sequence are not dramatic. They are not the stuff of disaster films. They are the ordinary process of science learning from nature. The system produced an event. The scientists watched. The engineers redesigned the boardwalk. The public, to the extent that it paid attention, learned something about a hazard it had not previously known about. The process is slow. It is iterative. It is incomplete. It is the best that can be done. The pool will continue to explode. The sensors will continue to record. The scientists will continue to analyze. The Park Service will continue to manage the risk. The public will continue to visit. And the system will continue to do what it has always done. The only question is whether the public will, over time, come to understand what that actually means. Projecting the future behavior of a hydrothermal system is an exercise in probabilistic reasoning. The system is complex. The number of variables is large. The data record is short relative to the timescales of the processes involved. The best that can be done is to characterize the distribution of possible futures and assign probabilities based on past behavior, physical understanding, and the current state of the system. The most probable trajectory at Black Diamond Pool over the next 12 months is continued small events. The conduit modification interpretation predicts that the elevated rate will persist and then gradually decay. The duration of the decay could be months or years. The published literature on similar post-event sequences at Yellowstone and elsewhere suggests timescales in that range. The 2026 events are occurring at a rate of approximately 1 per month. The rate could increase, it could decrease, it could remain stable. The most probable path is a slow decline over the next 1 to 3 years, with occasional clusters of events and periods of relative quiet. The pool will not return to its pre-2024 state in the next 12 months. The system has been perturbed. The perturbation will take time to dissipate. The probability of a larger event at Black Diamond Pool in the next 12 months is low. The historical record does not show a consistent pattern of small events leading to larger events at the same feature. The 2024 event was not preceded by an obvious small event precursor sequence. The Pork Chop event was not preceded by a clear sequence. The Mary Bay event left no precursor record. The absence of evidence is not evidence of absence, but the available data does not support the hypothesis that the 2026 sequence is a precursor to something larger. The probability is not zero, it is low. The best estimate, based on the frequency-magnitude distribution of hydrothermal explosions at Yellowstone, and on the behavior of similar systems elsewhere, is on the order of a few percent over the next 12 months. That is not a trivial probability. It is also not a probability that should drive public alarm. The probability of a basin-wide reorganization in Biscuit Basin over the next 12 months is also low. The sensor network at other features has not detected significant anomalies. The basin has been relatively quiet except for Black Diamond Pool. The most probable interpretation is that the activity is localized. The probability that it will spread to other features is not zero. The system is interconnected. The 1959 earthquake demonstrated that a large perturbation can propagate across the basin. The 2024 explosion was a much smaller perturbation. The probability that it will trigger changes at other features is correspondingly smaller. The best estimate is on the order of a few percent over the next 12 months. The probability of a pork chop scale or larger hydrothermal explosion somewhere in Yellowstone in the next 12 months is on the order of 1 in 20 to 1 in 30. This is the annual probability integrated across all thermal basins. It is the best estimate based on the historical record of the past 150 years and on the geological record of the past several thousand years. The estimate has substantial uncertainty. The sample size is small. The historical record includes the Pork Chop event in 1989, the Black Diamond Pool event in 2024, and several smaller events at other features. The rate could be higher or lower. The best estimate is the one the USGS uses in its hazard assessments. The probability is not trivial. It is high enough that an event of that scale is expected every few decades. The next such event could occur this year. It could occur in 10 years. It could occur in 50 years. The distribution is not predictable at the annual scale. The probability that such an event occurs in a basin that is open to the public, and that the ejection pattern intersects with where visitors are standing, and that the event produces fatalities, is much smaller. It is the product of several probabilities: the probability of an event, the probability that the event occurs in a high visitation area, the probability that the ejection pattern is harmful, and the probability that people are in the harmful zone. The product is small, it is not zero. The historical record of the past 150 years contains no fatalities from hydrothermal explosions. The historical record is not long enough to guarantee that the probability is zero. The best estimate is that the probability of a fatal hydrothermal explosion at Yellowstone in any given year is on the order of 1 in several hundred to 1 in several thousand. That is comparable to the probability of being struck by lightning. It is not negligible. It is also not high enough to justify closing the park. The future projections for the monitoring network are more certain than the projections for the hydrothermal system. The network at Black Diamond Pool will continue to operate. The data will continue to be collected. The USGS will continue to analyze the data and publish updates. The Park Service will continue to use the data to inform its decisions about basin closures and boardwalk placements. The scientific community will continue to publish papers, analyzing the sequence. The knowledge base will grow, the uncertainty will decrease. It will never disappear. The future projections for the public communication of hydrothermal hazards are less certain. The 2024 event produced a spike in public awareness. The 2026 sequence could produce another spike. Whether the public will retain an accurate mental model of the hazard is an open question. The research on public perception of low probability, high consequence events suggests that accurate mental models are difficult to maintain. The supervolcano framing is cognitively sticky. It fits the narrative templates that the public has been exposed to for decades. The hydrothermal explosion framing is less sticky. It is harder to remember. It is harder to visualize. It is harder to fit into a story about Yellowstone. The probability that the public will, after the 2026 sequence, have a more accurate mental model than it did before is modest. The probability that the accurate model will decay over time is high. The probability that the supervolcano framing will reassert itself is close to certainty. The future projections for the park's infrastructure are more straightforward. The boardwalk at Black Diamond Pool will remain closed until the pool stabilizes. The definition of stabilized is a policy decision, not a scientific one. The USGS will provide data. The Park Service will decide. The decision will be based on the frequency of small events, the trend in that frequency, the gas chemistry data, and the assessment of the probability of a larger event. The decision will be conservative. The Park Service will not reopen the basin unless the probability of a harmful event is judged to be very low. That judgment may take years. The pool may not stabilize in the next 12 months. It may not stabilize in the next 24 months. The basin could remain closed for an extended period. The future projections for other basins are similar. The Park Service will monitor the entire park with the instrumentation that exists. The instrumentation will be upgraded over time, subject to budget appropriations. The upgrades will be targeted at the features with the highest historical activity and the highest visitation. The park will never be fully instrumented. The cost would be prohibitive. The risk reduction would be modest. The residual risk will remain. It will be managed. It will not be eliminated. The long-term future projection for hydrothermal explosions at Yellowstone is the same as the long-term historical record. The system will continue to produce small events at a high frequency. It will continue to produce moderate events at a frequency of a few per century. It will continue to produce large events at a frequency of a few per millennium. It will continue to produce very large events of the Mary Bay scale at a frequency of a few per 10,000 years. The system is not changing in a way that suggests a departure from this long-term behavior. The elevated frequency at Black Diamond Pool is not a sign of a fundamental shift. It is a local perturbation. It will decay. The system will return to its baseline. The baseline is what it has always been, a hydrothermally active caldera that produces explosions on a wide range of scales, most of them too small to notice, some of them large enough to matter, a very few of them large enough to reshape the landscape. The future projection that matters most for human safety is not about the probability of an event. It is about the quality of the monitoring, the effectiveness of the communication, and the wisdom of the decisions made by the Park Service and the USGS. Those are human factors. They are not predictable from the geological record. They depend on funding, on political will, on public attention, on the skill and dedication of the scientists and rangers who do the work. The future projection that can be made with confidence is that the system will continue to produce events. The human response to those events will determine the level of risk that visitors face. The risk can be reduced. It cannot be eliminated. The webcam will continue to watch. The sensors will continue to record. The pool will continue to refill. Somewhere in the next 12 months, a 6th event will occur, then a 7th, then an 8th. Each event will add to the record. Each event will improve the understanding. Each event will be an opportunity to communicate the actual hazard to a public that has been looking at the wrong thing for 40 years. Whether that opportunity is taken is the question. The data is available. The footage exists. The scientists are ready. The only missing element is public attention that is sustained enough and directed accurately enough to make the communication stick. The story of Yellowstone has been told wrong for decades. The wrong story is about a supervolcano waiting to destroy civilization. It is about a magma chamber filling, an overdue eruption, a catastrophe that the government is hiding. The wrong story is cinematic. It is terrifying. It is also, on every timescale that matters to a human life, the wrong story to be telling. The right story is smaller. It is about a pool of near-boiling water in a closed-off corner of the park. It is about a webcam mounted on a broken boardwalk. It is about 5 explosions in 5 months. It is about the physics of hot water under pressure, sealed by minerals that precipitate out of the water itself, failing when the pressure exceeds the strength of the seal. The right story is about a system that has been doing the same thing for hundreds of thousands of years. It is about the second most likely hazard at Yellowstone, the one that occurs multiple times per year somewhere in the park, the one that the public has never been taught to see. The right story is not about the end of the world. It is about the boardwalk you walk on. It is about the pool you pause to photograph. It is about the distance between where you stand and where the rocks might land. The right story is about risk management. It is about monitoring. It is about communication. It is about the decisions that the National Park Service and the USGS make every day, based on the best available data, to keep millions of visitors safe while allowing them to experience one of the most geologically active places on Earth. The right story is also about uncertainty. The scientists who study hydrothermal explosions do not know when the next moderate event will occur. They do not know which basin it will happen in. They do not know whether the boardwalk distances at Old Faithful, or Norris, or Mammoth are sufficient for the ejection pattern of the next event. They have probabilities. They have best estimates. They do not have certainty. The uncertainty is not a failure of science. It is a property of the system. The system is complex. The processes are non-linear. The warning time is 0. The best that can be done is to monitor, to learn, and to update the assessments as new data comes in. The Black Diamond Pool Monitoring Network is a model for what could be done elsewhere. The seismometer, the infrasound array, the pressure transducer, the thermistor, the gas sampler, and the webcam together provide a level of detail that was unimaginable a decade ago. The data from this network is already improving the understanding of hydrothermal explosion mechanisms. It will continue to improve that understanding for years to come. The question is whether this level of monitoring will be extended to other features in other basins. The answer depends on funding. It depends on prioritization. It depends on whether the public, having been told the right story, supports the investment. The 2024 event was a wake-up call. It was the first time that a hydrothermal explosion at Yellowstone was captured on viral video. It reached millions of people. It introduced the term hydrothermal explosion into the popular vocabulary. It did not, however, fundamentally change the public's mental model of Yellowstone. The supervolcano framing reasserted itself. The hydrothermal explosion was processed as a curiosity, a tangent to the main story. The 2026 sequence is a second chance. 5 events in 5 months, a webcam recording in clear light, a sensor network producing data in real time. The opportunity to tell the right story is here again. Whether it will be taken depends on the choices made by journalists, by educators, by the USGS, by the Park Service, and by the public. The reframe that is needed is not complicated. It does not require a PhD in volcanology. It requires only that the actual hazard ranking be communicated clearly and repeatedly. The supervolcano is the least likely category of hazardous event at Yellowstone. Hydrothermal explosions are the second most likely. Large earthquakes are the most likely. That is the ranking. It is not disputed by serious researchers. It is grounded in the data. It is the foundation of the USGS's own hazard assessments. The public has never been told this clearly enough, often enough, to internalize it. The reframe also requires that the public understand what a hydrothermal explosion is. It is not a volcanic eruption. It does not involve magma reaching the surface. It is the flash boiling of superheated water trapped beneath a sealed conduit. The energy comes from the heat of the magma chamber, but the explosion itself is driven by water turning to steam. The mechanism is simple. The consequences are local. A moderate hydrothermal explosion can destroy a boardwalk, eject rocks, and kill anyone standing in the wrong place. It cannot destroy a city. It cannot alter the climate of the Northern Hemisphere. It is a local hazard. It is also, on a human timescale, a much more relevant hazard than the supervolcano. The reframe does not require that the public be afraid of visiting Yellowstone. The probability of being harmed by a hydrothermal explosion on any given visit is extremely small. It is smaller than the probability of being in a car accident on the way to the park. The risk is real, but it is not large. The purpose of the reframe is not to scare people. It is to provide an accurate mental model. It is to enable informed consent. Visitors should know what the hazards are. They should know that the boardwalk distances are engineering judgments, not guarantees. They should know that the 2024 event was a near miss. They should know that the system is active and that the small events at Black Diamond Pool are the system doing what it does. That knowledge does not need to produce fear. It needs to produce awareness. Awareness is the foundation of safety. The final reframe is about attention. The public has been paying attention to the wrong thing. The media has been directing attention to the wrong thing. The documentary filmmakers, the disaster fiction writers, the click-driven news outlets, all of them have been telling the dramatic story because the dramatic story sells. The hydrothermal explosion story is less dramatic. It is not about the end of the world. It is about a pool in a basin on a Tuesday morning. It is about a webcam that recorded 12 seconds of lifted water and falling rocks. It is about a sensor network that is slowly, patiently, building a dataset that will improve the understanding of a poorly understood hazard. That story is not cinematic, it is not terrifying. It is real. The webcam at Black Diamond Pool is still watching. The sensors are still recording. The pool is still refilling. Somewhere in the next 12 months, a sixth event will occur. It will be recorded, it will be analysed, it will be added to the record. It will be an opportunity to tell the right story again. Whether the public is ready to hear it is the question that will determine how the next event is processed. Will it be another curiosity, another footnote to the supervolcano story? Or will it be understood as what it is? A small expression of the system that has been operating for hundreds of thousands of years. A reminder that the actual dangerous thing about Yellowstone is not the imagined catastrophe, but the real one already happening, on a boardwalk near a pool, on a clear morning, in front of a webcam that never blinks. The data is public. The footage exists. The scientists are ready. The only missing element is the public's willingness to look at what is actually there, rather than at what the imagination has built. The pool will continue to explode. The question is whether we will finally see it